Welcome. Today, well, we will be finishing up the parser, I guess. Request. Go. No. I think it's in my CMD TCP listener main.go. Yeah, there you go. So we're gonna make a quick video today because I don't got too much time. So day 235, going strong still. Just a little bit every day, so it's fine. Time to end and then test our full HTTP parse request parsing. We did the hard parts. Update your application to the request line. So yeah, let's do that. Alright, so let me just do this. The body. Body strings. So I think we can do we'll do body string. It's S, but let's do R dot body. Probably need to convert this to a string. Okay, how's it look? Yep. All right. Go test, or let's do this. This. Boom. Really nice. And then kill this. Kill that. Cat / temp body. Pretty nice. So let's get that going. All right. Chugging along pretty slow. Take a look at the struct we've been parsing into request. Request line headers, body. Now compare it to official proto method URL header. We have request line struct while they elevated the method target version into their own top level fields. We have a request line while they've elevated the method into their own top level fields. It's basically the same data, but the layout is a bit different. We have header struct. They named theirs header. Again, same data, slightly different layout and naming. I prefer them called headers because that's usually how web developers refer to them. The Go standard refers to an entire collection of fields as a header, but I digress. The most important difference is the body field that just stores the entire body as a byte while in memory. It's the reader clear interface. It's perhaps simpler, but it's more limiting to the users of our library. We force them to load the entire body into memory before interacting with it. The Go standard allows them to use it to read the body in chunks or even stream it to a file, which is often necessary for large body. How does Go's HTTP request handle the body differently? What's that fucking bomb out there? How does Ghost HTTP requests handle the body differently? It streams the IO closer instead of. Okay, yeah.
Now, whether you're getting your data from YouTube or Twitter, every single server has implemented the HTTP protocol, which remember is on top of TCP. Though that technically may be a lie, with HTTP 3, it's actually on top of UDP, which actually implements a form of TCP on top of UDP. Bing! Now, not all the implementations of HTTP are perfectly identical. If you go off and you peruse some of the horror stories, there's like these very little things that didn't work out. I can think of one time at Netflix in 2016 in which I actually got hit with a bug because, guess what? Headers were being parsed case sensitive, not case insensitive, on a specific TV. Not every implementation is equal. But if you were to implement a server now and say you used Go, you could use something called the HTTP package. It's already available. You could start TCP servers or you could start UDP servers in Go. You don't have to implement these because at some point somebody implemented all of this and put this into the standard library. If you're to use Rust, you'd actually have to use Cargo to be able to install an HTTP server, but Rust does have a TCP server. Every single time somebody has to implement it at some point, and we have a specification to hopefully make sure every implementation is the same. Headers, they should be case insensitive. The status line should look a certain way. If you've broken any of these rules, hopefully you're getting back a 400, a bad request. The basic life cycle of any HTTP request usually comes from the client. Now, this client will send off something called a request. Now, this is just a subform of the HTTP message specified in the HTTP specification. There's a lot of specification I just said there. And this usually will consist of what is called a status line, field lines, and a optional body. It can also include trailers at the end. Trailers are just simply headers, but they're computed at the end. You can think about this when it comes to, say, really large file uploads. We don't know how big this file is gonna be, but we're gonna send you a bunch of data, and at the end, we want to send you, say, a checksum. That checksum needs to be dynamically computed, so therefore that checksum won't be known until the end, so we will have a trailer at the end of the request. So now every single request is gonna go across the wire. It's probably gonna be passed through many different implementations because every single connection along the way is gonna be forwarding the request onto the final destination, the server. And when the connection gets to the server, it's gonna parse out the status line. That status line is gonna say, hey, here's where it needs to be routed within the server. It's then gonna go from there and make sure that it has everything parsed, the query parameters, all the stuff that your server does. And then you're able to go off to, say, the database and get any information you want, maybe go out to a third-party service, maybe even call good old-fashioned ChatGPT to get a response back, and then you're gonna send that back with what is called a response message. The response message is gonna be identical shaped as a request message. You're gonna have a response line, you're gonna have field lines, and you're gonna have an optional body, and of course, an optional trailer at the end. Trailers obviously for chunked encoding. This is the request response model of HTTP. Notice that in TCP, there is no request response model. It is simply forming data and being able to have that same shaped data be both on the client and on the server. There's no kind of responsibility of the server now to respond to something. Whereas with HTTP, it's also implementing a behavior on top saying, hey, when I do a request, I expect back a response. The response should have status codes that kind of indicate if it was successful or not. That's why often you'll see something called a 200 status code. That just simply means, okay, that was good. I believe it's literally called status okay. A 400 is simply just a bad request. Maybe you didn't provide the right information for the request. A 404, which we've all seen, is simply means that, hey, not found. We couldn't find it. So every single response comes back with more than just simply the information you're looking for, but also the status about the information. Obviously, not every single language is gonna be great for the request response model. If you take something like Node, if you have a high compute task in a JavaScript environment, since JavaScript is only single-threaded, you could actually greatly affect your request response per second. Typically, though, most people's handlers are actually pretty thin, and it's just a series of grabbing a bunch of data from some external sources and then taking that data, putting it into some sort of formed object, and then sending it down to the client. So they're very, very light, barely affecting the RPS itself.
Alright, let's just set this one up and then call it a day. HTTP server. And I'll go. Package main. Okay. I don't know if this is supposed to be main. And then in our internal, we'll create a server. It's called a what do I call this actually? Okay, yeah, we'll call it server.go. Server.go. We'll handle that later. Let's do HTTP server. Okay. We'll have this. I'm assuming we're gonna have something like this pattern, you know. We'll have like type, oops, type or yeah, type server struct. We'll have a bunch of stuff to do in here. I'm not sure exactly the fields. Probably like our request and response, maybe. But I don't know. Or maybe a response field, but I'm not trying to guess. Obviously, we'll have a func s for server, and then server here, and then we'll have the not parse serve serve. I guess it'll take a port, so I guess port int. Oh yeah, exactly. I'll return an instance of a server and error. Yeah. And error. Returns a new server instance. Starts listening for requests inside our go routine. Okay, let's do it. Let's try to finish this up, I guess. In your server package, implement the following. Implement the following methods. I won't hold your hand here much. All right. Okay, we'll create all the methods. So let's create 3p. So there's how many methods? 1, 2, 3, 4. I guess 4. So we have serve, close, listen. You don't need any of these. with the import net. Wait, what are the fields here? I got the close can definitely error out. Let's do this. So we do L net dot listen. I have the port. It's TCP, right? Can I convert this to a string? Use an L. So we have a listener object. We definitely should close. I don't want to close it though. I guess we'll have a listener. List. No, wait, I don't know. I don't know what exactly this server should have. Well, anyways, I think I have to go soon, so call it a day to here. Anyways, thanks for watching. I'll see you tomorrow. Peace.